Section 3.5, solving an application problem involving a system of three equations. When production lines A, B, and C are all working, 3,500 prints can be made in a day. When only A and B are working, 2,000 prints can be made in a day. When only B and C are working, 2,300 prints can be made in a day. How many prints can be made by each production line working along? So let's set up our variables. We'll let A equal line A, B equal line B, and C equal the production of line C. In the first sentence, it tells us when all three are running, we end up with 3,500 prints. So we would have production of line A plus production of line B plus production of line C equals the 3,500. In the next sentence, it says when only A and B are working, 2,000 prints are produced. So we have an A plus B equals 2,000 prints. The third sentence tells us when only B and C are working, so B plus C, have a production of the 2,300 prints being made. Well, we don't have our triangular form to solve this system, so that's what we need to do. We have some holes here, so it's looking promising. So to solve this, let me number our equations. So we have a starting point, leaving the first equation as the standard in our triangular elimination method. Going to multiply, just for a change up, multiply the second equation by a -1 and then add it to the first equation. Well, multiplying by a -1 with the idea of eliminating this A will give us a -A, a -B, and multiplying 2,000 by a -1 gives us a -2,000. Equation number 1 will leave as is, which is an A plus B plus C equals the 3,500. We'll add these two together to give us our new equation number 2. Well, the goal was to get rid of the A. We not only got rid of the A, but we also got rid of the B, leaving a C equal to 3,500 minus 2,000 is 1,500. And normally we still would have to do something to get our variables lined up in that triangular form, but because our third equation doesn't have an A, it only has two variables, and we know the value of one of the variables, all we need to do is to take equation number 3, which is B plus C, but replace C with the value that we just found and set it equal to our 2,300. Solving for B, we will subtract 1,500 from each side, leaving us with B equal to, the difference here is 800. Now we know two of the three. We can go back to our first equation, which is A, we don't know, plus B, we just found, plus C is equal to our 3,500. Plugging these in, we will add these two numbers together, which gives us 2,300. Subtract a 2,300 from each side, leaves us with A is equal to 1,200. So to answer this problem, we would say line A has a production of 1,200 prints in a day, B has 800 prints, and C has 1,500 prints. We could check this. If you add up these three, we would have 1,200 plus 800 is 2,000 plus our 1,500 is the 3,500. using any one of the a, b, c values in our other two equations should also hold true and give us an indication that our problem was solved correctly.